Good evening, everyone. Are you able to hear my voice? Hello? Can you hear my voice? Please say anyone tell, then I can start the class. Hello?
Listen, yeah.
Yeah. Okay, fine. Okay, so last week Sart taught this Miller indices, basic crystal structure as well as XRD and point defect. Okay, I hope you know already. Maybe you went to the class, I think, imperfections in solid. That is the main title what he taught. Okay, so we will start from the normal basic problem which we have seen in the assignments, but I'm not going to solve assignment here. I'm not supposed to solve also. So you will get some basic idea of it. Okay. So see the first question. The closest packing sequence ABAB represent which crystal system? HCP, BCC, FCC or symbol cubic? Okay, so what will be the answer? The closest closing packing of AB represent the hexagonal packing. Okay, I hope hexagonal packing you already know it. And similarly, the AAA type will be primitive cubic packing. ABC type will be sphere of third layer spacing representing FCC cubic packing, and ABC will be the hexagonal packing also, but it will be the layered placed in tetragonal how the voids will be accordingly. Okay, and BC structure has no close packing planes. So this is the first question answer. Okay, so it's very easy question. So please do the next one by yourself, because this already we have explained last time, like how many number of atom in each plane. Okay, the number of atoms centered in the 111 plane for FCC structure is set. So please check it how it will. Do it yourself, then we will solve it here. Did anyone got the answer?
Is it too?
Yeah, two atoms. But we have to see three different planes, right? One is 100 plane, 110 plane, and 111 plane. So each plane you have to find what will be the number of atoms. Like question is 1 1 1 plane, but you can try other two plane also. 1 0 0 1 1 0. So how it will be? Okay, so
24100 plane.
so if it is like this 1 1 1 plane, what the plane look will be look like this. Okay, so there will be atom in the corners and middle of the plane also, like it's touching each those three planes. So it will be atoms like this. Okay, so total contribution will be what? 3 atoms in the face, so 3 into 1 by 6 plus 3 atom in the corner, 3 into 1 by 2. So it will be total 2 atoms. So that will be 1 1 1 plane. Now, for this 1 0 0 plane, how many atom will be there in FCC? Corner 4 atoms plus 1 face 1 atom, right? In this plane. This is simple cubic I have given, but you have to imagine if FCC how it will be. So 1 0 0 plane, how it will be? There are 4 atoms, 1 by 4th sharing plus 1 into 1 atom in the face. So total it will be 2 atoms. Okay, now if it's a plane is like this, hmm, like 1 1 0 plane. 1 1 0 plane means the middle plane is crossing the diagonal. Okay, so it will be like 4 atoms in the corner and 2 atom projections will be there. Okay, like face will be face atom, 2 atom will be here. So totally how many atoms will be there? 4 into 1 by 4 plus 1 into 1. So total, sorry, it will be 4 into 1 by 4 plus 2 into 1 by 2, 2 face ended atom plus 2 into 1. So it will be total 4 atoms within the cell. Okay, so this will be the answer for it. Now we will go to the another problem. Derive the planar density expression for FCC 111 plane in terms of atomic radius r. Okay. So if it is a plane 111 plane, what will happen? It is like a diagonal, this plane, whatever we are seeing here, this plane. Okay. So that atom will be like this, corner atom and 3 face atoms. So the planar density, what is the formula? That is equal to number of atoms centered on 111 plane divided by area of 111 plane. Okay. So please calculate it using equation, then we will solve the remaining. Answer you please keep it in chat box. What it will. So see this is the way we have to solve it. So number of atoms centered on 111 plane, it will be 1 by 6 into 3 plus 1 by it went 1 by 2 into 3. Okay, so total number of atom will be 2. Then what will happen? Area, we have to find the area, so means we have to get r in terms of r, right? So the half of the circle, then it will be 2r square plus h square is equal to 4r whole square. Okay, then h will be 2r root 2. From there area will be 4rh by 2, then that you can get it like this and substitute in the planar density equation. So 1 over 2r square root 3. So that will be the answer. Now let us go to the next problem. Determine for copper the linear density of atom along 110 direction. Okay, so 110 direction which is given. Okay, now you have to find the linear density. So linear density will be that is equal to the number of atoms centered on direction divided by length of direction vector. Okay, so now just this is the vector, so just count the number of atoms and do it and let us know. We will discuss later after some time. Just you find the try to find the answer of it.
So we have to consider the radius of that.
What?
We need to consider the radius of that
In terms of radius of atom.
for copper. 0.5 atom.
0.5 divided by r, right?
Yeah.
Okay.
I do have a doubt in this.
What?
Hello. Like we are calculating this linear density, planar density. Where can we use all of that? All this calculation in real life.
Some
Can
application
you
like
give some?
see if XRD application and all you can use it, which plane the light is coming and reflecting. So those things we need it.
Sorry, where can we use it?
No, in XRD and all, the light will come and incident on in a plane and go right. So how will be the atom density in that plane? So you can calculate like this. Some experimental application. So here it will be 1 over 2 atoms plus 1 atom plus 1 over 2 atom divided by total radius. How it will be? R, 2r, then r, it will be 4r. Okay, so it will be 2 atoms by 4r, it will be 1 over 2r. So that will be the answer. Now let us go to the next problem. The problem is, for BCC iron, compute A interplanar spacing, B diffraction angle for the 2 to 0 set of planes, lattice parameter of F is given, and also assume that monochromatic radiation wavelength is given, used to for the order of reflection 1. Okay, so given data is our data are what? A is equal to 0.2866 nanometer and H is equal to 2, K is equal to 2, L is equal to 0. Okay, you can use this DHKL is equal to A by root of H square plus K square plus L square formula and find the value A is given, then you will get the interplanar spacing. After that, what you can do? Sin theta is equal to m lambda by 2 DHKL. Substitute all the values, it's already given. You have to find the theta value from that. Okay, then you have to get the diffraction angle 2 theta. So that is the solution, you have to do it. So please try and first find what will be the D value. Okay, then we can answer the B question, that will be theta value. Okay. So how much we are getting answer? You have to substitute. It is equal to 0.86 divided by root of 2 square plus 2 square plus 0 square. So you will get the answer approximately 0.1013 nanometer. Okay. After that sine theta you have to substitute all the values. 1 star 0.1790 nanometer divided by 2 star 0.1013 nanometer. Okay, so if both are nanometer, it will get cancelled, then it will be 0.884. Okay, sine theta, and theta will be sine inverse of this, it will be 62.13 degree. Now 2 theta will be 124.26 degree.
And how can we find this reflection angle for some other non-cuboidal structure?
What? How you get?
We have to find reflection angle for some non-cuboidal structure. Then how
I
can
can't hear your voice, it's not clear actually. Hmm.
doesn't that if we have to find reflection angle for non-cuboidal structure, then how can we
Diffraction angle for?
non-cuboidal structure, non-cubic structure?
Non-cubic structure, then this a by that value you have to change. If it is cubic, here a is same, right? So non-cubic will be a by plus like b by like that it will be there. You have to separately do it.
So we have to do it for HCB then.
Separately.
Then how can we do it?
Hmm. That I will tell you one. Hmm. Actual formula for this is actually d is equal to like d is equal to 1 over root of h square by a square plus k square by b square plus l square by c square. Okay. If a equal to b equal to c, then this you can represent as a by root of h square plus k square plus l square. Otherwise, if a is equal to not equal to b, like trigonal system or whatever it is, or theoremic a equal to b not equal to c. So such kind of system, what you have to do, you have to give separately to find d value. This is the general formula. Here we are writing for only for cubic. That's all. Simple cubic system.
Yes. And if you have to represent this interplanar spacing, then how can we do it?
What? If we?
We have to represent this interplanar spacing,
Hmm.
the explain. Then how can we represent it? Can you show that?
Representation of interplanar placing you're asking.
Yeah.
That's only this one D.
Yeah, DHL. We have calculated na 0.101.
Hmm.
And actually we have to represent it in form of figure. Then how can we represent?
Representing some of?
Represent a dimension in figure. How can we represent it? Like which dimension is
Oh, its length, nanometer.
that's correct.
Huh,
But
like,
let's say we are calculating interplanar spacings for 111 plane in cubic structure.
but any of the dimension will be length, right?
Yeah, it will be length, but which length? Want to know?
Okay, you are actually asking actually what is D, right?
Yeah. Like, can you represent it in terms of figure or between which dimension is it between two planes?
Like space means it will be spacing between two planes, right? Normally,
Yeah.
see, even XRD used to do that. Okay, so see here, these are the atoms. Okay, mm, and light is coming. We can call this point A, this point B. Okay, so light is coming and reflecting from here. Okay, so this angle is theta, we are calling. So if you draw a perpendicular here, okay, this will be, okay, this will be, so this distance in between two planes, that is interplanar distance D.
Yeah, that's correct. But if we have to show it in form of a unit cell, then like how can we do it?
In form of a unit cell, it is not in form of a unit cell. See, it's like a proper
Like
material.
we have drawn a unit cell, we have drawn a plane in that.
Huh, if it is a unit cell, it's depend which plane the light is incident on that. Okay, we cannot represent it is
Let's
in if, for example, if you want, you can calculate like two planes, like upper plane, like 100 plane, and the below one also, like that, in between this, or in between two faces, FCs, like two faces of that, or in between two diagonal planes of two different unit cell. All this you can calculate, but here only dependence is, it's not like which plane it is, it depends on the angle here mainly. And this normally interplanar distance is coming between, like, see what are the dependence values of interplanar. If D formula, D is equal to the HKL values of the plane, how it will be, HKL how it is
well,
coming from the Miller
well,
indices.
let's say we are doing it for a 111.
Hmm.
Then like
One will
which
be
is
here, it will be one square plus one square plus one square, that's it. How the plane is tilted, or how the plane look like, it will come in this term, the below denominator term. Okay, and A will be the your unit cell length. So ultimately, it's also representing the unit cell property and where the plane is coming. Okay, and how the light is incident on it. Now we will move to the next question. Next question is very basic question. Anyone can answer it. How the density of crystal decreases due to the Schottky defect and remain constant due to the Frankel defect. Density of crystal structure decreases due to Schottky defect. So you should know what is Schottky defect, what is Frankel defect, then you can understand the answer for it. So can anyone tell what is Schottky defect and what is Frankel defect?
Is due to short defect vacancy
So
Frankel defect is pair of vacancy in interstitial vessel.
yeah, Schottky defect is type of point defect in the crystal. Normally in ionic crystals, you can see that the defect form how when the oppositely charged ion leave their lattice site and creating the vacancies. Okay, so these vacancies are formed in stoichiometric unit like to maintain the overall neutral charges of the ionic solid. So the vacancies are then free to move about as their own entities. So normally this effect will not change the and the effect will decrease the crystal density. But in case of Frankel defect, what is Frankel defect? Frankel defect consists of a displacement of an atom from the lattice position to some interstitial site. So atoms are not going out of the lattice. So density at last what will happen? It will move some other position interstitial space where the vacancy filling is there some other spaces. So ultimately the total number of atoms are same in the lattice, so the density won't change. It will keep it as constant. Okay.
Which in which condition
In Frankel
Frankel defect will
condition,
be
in
formed?
Frankel condition, density won't affect, but in
Let us but in which condition Frankel defect will be formed?
which condition means what you're saying.
Like when Frankel defect will be due to any process or what? Like there might be some condition that
Oh, like
if
you're
you will do
asking
this,
about fact.
if you will do this, then Frankel defect will be formed.
Oh, that's some heating process or something. Like some external parameters should be there,
Like
like temperature or strain to the system.
I got to
Hmm?
vacancy is also formed by retaining this
It will form.
vacancy. So like how can we differentiate that? Frankel defect will be formed by vacancy.
that we have to see the atomic positions properly, how were the atoms are like. So actually for fungal defect and all there is one formula for that. So the formula term will depend on this activation energy and Boltzmann constant and temperature. So mainly temperature will cause the fungal defect. So you can calculate like that, which happened or not from the.
Like we are hitting a material, uh, then there is a possibility that it will form a vacancy or it can form a frontal defect again. So how can we differentiate that? One frontal defect will be formed or a vacancy will be formed?
Experimentally, normally people do with XRD actually. From XRD, you can see the atomic arrangement, the atoms are in proper place or not. So, if it is a displaced like Schottky defect, then the diffraction pattern will be different. The atomic, like where the light normally atom will be orderly arranged, and we will see the light is going, and we will get a extra like diffraction pattern. When if it is not in the same place or it's shifted, like Frankel defect and like Schottky defect, if we go to in this interstitial site, then the pattern will be disturbed, and it we can measure the theta angle differently. So from that you can go do it in experimental.
But that is after the defect is formed. Like,
Huh, after the defective form only, then only we have to measure, right? Before why you have to?
Like how can we tell like if we will process a material in this condition, then
Mm-hmm.
there is a possibility. How can we tell that if we will process material in this condition, then a Frankel effect can form, or in other condition a vacancy can be formed, can be formed. How can we determine that?
So that we have to see the XRD pattern of the crystal. We cannot simply say after heating it changed or not. Maybe phase transition also happen. It depends on each material. It's only defective or the complete crystal structure changed or not from external parameter. There are several external parameters like you can apply pressure to the system. That time also defect can happen, and you can apply strain to the system, the angle tangential strain to the system and longitudinal strain also. And you can apply temperature. That's also one parameter which change the atomic structure and phase of its phase group value. It's completely, it will change the phase of the crystals.
Yeah, but are there any specific condition
No, no, we cannot predict
to form?
like it's changed or not. For that, we have to clearly see the XID pattern, then get the phase transition of that. And actually, there are one more technique called angle resolved photoelectron spectroscopy. After using that, also you can do it. You can clearly see the atomic arrangement, and you can get it. The it's like a dotted line, like exactly the atomic arrangement like this, where the atoms are. From there also you can find it actually. It's defective or not. The basic defect and all. If a higher part, then we can't. Okay, now we'll go to the next problem. What is the composition in atom percentage of alloy that contain 45.2 kilogram copper, 46.3 kilogram zinc and 0.95 kilogram lead? So here you what you have to do, you have to find its mass is given, you have to find the number of moles in each case, then the composition formula of composition Cu, it will be 100 times NCU divided by NCU plus NZN plus NPB. So this is the basic formula you have to use, but N is number of moles, so you have to find number of moles in each case. And there will be one more data which is given, that is mass of copper, that is 45200 gram. M dash of zinc, it will be 46300 gram, and M dash of Pb will be 150. And the molar formula will be N of copper is equal to M dash of copper divided by copper atomic mass. So you can write it 4520 divided by 63.55. Similarly, atomic mass of zinc will be 65.41. Atomic mass of Pb will be 207.2 gram per mole. I hope you got the answer for this. Now substitute here. We will get 50.0. Similarly, C you will get 49.7 and CPB will get 0.3 in percentage. Now we'll go to the next problem. What is the composition in atom percentage of an alloy that contains 45.2 kilogram copper, zinc and lead? Oh, so I think we have already done that. So next one is calculate the activation energy for vacancy formation in aluminium. Given that the equilibrium number of vacancies at 500 degrees Celsius is 7.55 into 10 to the power 23 meter per meter cube. So the atomic weight and of and density of aluminium are given. So you have to find the activation energy. So the formula will be Q is equal to KT log NB divided by N. So N is the related to the density and Avogadro number and atomic weight. So N of is equal to rho of Al and Avogadro number divided by atomic mass of Al. Okay, substitute all the values, it's already given. We will find the answer N value, then substitute that in the Substitute the values first. Okay, so next question is stacking sequence of FHCP system. Like was the first problem what we have solved today, similar kind of problem, but how the stacking will be, that's what we have to see, what it does mean.
No, I have doubt this
Yeah,
enthalpy.
yeah, you
Like,
can.
what is this enthalpy of formation of vacancy?
What is that?
Enthalpy of formation of vacancy.
You're asking from the last question, right?
Not exactly from last, but I think it's relatable. That's why I said. Well, I am unable to understand that.
Like
Like, what
enthalpy
is
of
this?
formation you're asking, right?
The enthalpy of formation of vacancy.
Actually, the enthalpy formation means like energy releasing or consuming when one mole of substance is created. Okay, that is the normally enthalpy of formation. Okay, so which
But like when one vacancy is formed, how much energy is consumed? Like that?
yes, like when if two molecules are joining and forming a substance or forming of a formation of a crystal, like there will be forces, right? Definitely.
Yeah.
Atomic forces, so that energy will transform when it creating, sometime the energy will release, sometime the energy will consume, that amount of energy for one mole of substance, how much, that we can call it as enthalpy of formation. Okay,
Okay. Any in case of
in case of
vacancy, it will be always energy consumption or
uh, energy release will be there because atomic bonds will break. That interaction, it's not a bonding, actually the van der Waals force will change in between, because each atom has van der Waals force between each other, right? Next neighboring atoms. If the
yeah.
vacancy time it is moving means that energy is like okay. Mhm. So that enthalpy means to break the, if the force is very high, to break the van der Waals force or whatever the force between the atoms, then you have to give the energy to the system. That's what we are actually giving, applying by temperature or pressurizing the system. It is transforming.
Like, how can we calculate it?
That's the formula which we have done last time. Like normally enthalpy of formation, it will be change in enthalpy. So normal basic thermodynamic formula you can use it for that.
Okay.
Okay, so this is the hexagonal packing. There will be three atoms inside also. So if you see the first layer, if we can call it as this arrangement as A. The second layer will be B. Again, the third wire similar to the first layer, so we can call it A. Now, if another unit cell, then there will be B. So here, that's why we are hexagonal packing. It will be AB, AB stacking. Now, can you people try the next question? Number of atoms centered in one plane direction of a BCC. Here I am asking BCC because the first question what we have tried, it is in FCC. So similar way you can try in for BCC also, and please let me know what will be the answer.
3 and 2.
Yeah. Let's others also try. It is similar to how we solved the first problem. Similar. So it will be 2. So you can calculate this also. This also similar kind of problem, but we have solved earlier. A monochromatic light beam of wavelength. It's here also d value you have to find. Then apply that in the 2D sin theta is equal to n lambda. Find the theta value. Okay, so here you have to find the enthalpy of formation. So the vacancy concentration of crystal doubles itself between 25 degrees Celsius to 31 degrees Celsius. Enthalpy of formation of vacancies in kilojoule. So that's what we have to find it. So here how to do is like formulas is equal to n e to the power minus q by kt in Kelvin. Okay. So here disorder will increase. So you have to find this for 25 degrees Celsius what it will be, and you have to find n is equal to 31 degrees Celsius what it will be. So substitute all the values, you will get n e z to the power q divided by k into 298. So here it will be n e to the power minus q divided by k into 304. Okay, now we know that n 31 degree that is equal to double of n 25 degree. So substitute the values and cancel each other. You will get e to the power q divided by 298k minus q divided by 307k that is equal to 2. From there we can get it q by k into 1 over 298 minus 1 over 304 is equal to log 2. From the you have to find the substitute the k value, substitute, then you will get the value for q. So q will be q is equal to k into remaining all number its numbers, you can calculate it and you will get 10 to the power 4. Okay, then substitute k value, it will be in electron volt, so it will be 8.62 into 10 to the power 5, 8.62 into 10 to the power 5 into the above term, then finally you will get 87 kilojoule per mole. So everyone please try it.
Now can you repeat this explanation?
What?
Can you explain current?
Yeah, actually, you have to find the enthalpy of formation. Okay, so there are two conditions, 25 degrees Celsius and 31 degrees Celsius. So you have to apply both the condition and see what is the difference is happening there. So here N31 and N25, this will be the formula. So convert the temperature into Kelvin and you will get the relative formula like this. And the question itself, it is given doubling. Okay, crystal double itself, vacancy of concentration. So N31 will be 2 of N25. So substitute the formula. Okay, then you have to find the q value. To find the q value, you have to take log on both sides. Then what you will get, it will be q divided by k into the temperature difference is equal to log 2, you will get it. From there, you have to get q this side and keep every numbers in the right side. Then you will, after solving it, you will get it will be k into 1.049 into 10 to the power 4. Now substitute k value. This then that is 0.8.62 into 10 to the power minus 5. Then you will get the theta value. Theta value will be actually 0.9 electron volt that you have to convert into kilojoule. Then it will be 87 kilojoule. Actually, it is 0.9 electron volt. try to solve these problems. Activation energy also we have calculated. Use the same formula here.